objects is given by NCR equals n factorial over r factorial times the factorial of n minus r, where n and r, where our n and r are positive integers, and r is greater than or equal to 1 and less than or equal to n. Now, let's have the following examples. Example number 1, how many triangles can be drawn on a plane using 4 non-collinear points? Remember that a triangle is formed by connecting 3 non-collinear points where a segment is between pairs of points. Therefore, a triangle should have 3 non-collinear points. Moreover, the order of connecting the points in a triangle will not matter. Because anyway, with the same points, you will have the same triangle. But since the order does not matter, this tells us that drawing a triangle or drawing triangles from 4 non-collinear points is a combination. But the question is, how many triangles can be formed with these 4 non-collinear points? Let us answer that problem. Using our formula, we have the combination of n taken r equals n factorial over r factorial times the factorial of n minus r. With this problem, our n is equal to 4 since we have 4 non-collinear points, and our r is equal to 3. And this is because to form a triangle, we only need 3 points out of the 4. Now, substituting these values, we have 4 C3, or the combination of 4 taken 3 equals 4 factorial over 3 factorial times 4 minus 3 factorial. This then gives us 4 factorial is 24 over 3 factorial is 6 and 4 minus 3 is 1 factorial, we have 1. Or we can simply write it as 6. 24 divided by 6, we get 4. Therefore, using our formula, we can say that 4 triangles can be formed using 4 non-collinear points. But let us see or check whether this is true. Now, let's say we have 4 non-collinear points. Connecting these 3 points will give us our first triangle. Then this one, or these 3 points, will then give us our second triangle. Now, if we draw this line or segment, we have another triangle, which is the third triangle in this case. And our last triangle, or the fourth triangle, is this. So again, we have 1, 2, 3, and 4. So we say that with 4 non-collinear points, we can have 4 triangles. A committee of 5 students is to be chosen from 10 boys and 11 girls. How many committees can be formed if the committee is to be comprised as follows? For the first item, we have there are no restrictions. With this, we have the combination of, since we have no restrictions, our n would be 21. Since we have 10 boys So the combination of 21 students taken 5 students. Our N is 5, our N is 21. Since we have 21 students and our R is 5, since we only need to choose 5 students to form our committee. Equals, we have 21 factorial over 5 factorial times 21 minus 5 factorial. This then gives us 21 factorial over 5 factorial times 16 factorial. So we have 21 factorial times 16 factorial. Our quotient then would be 20,349. This tells us that there will be 20,349 possible committees that can be formed, choosing 5 students out of the 21 students. For our next item, we have all our boys. This is our condition, meaning the committee will be comprised of all boys. No girl will be chosen. So with this, we have 10. We have the combination of 10 taken 5. The combination of 10 taken 5, meaning out of 10 boys, we will be choosing 5 to form our committee. Then multiply it to the combination of 11 taken 0, because there will be 0 girl or no girl to be chosen out of the 11. Since only boys. With this, we have 10 factorial over 5 factorial times 10 minus 5 factorial. Multiply it to 11 factorial over 0 factorial times 11 minus 0 factorial. And 10 factorial is equal to 3,628,800 over 5 factorial times, so we have 120, 5 factorial, and then multiplying it to again 120 times 11 factorial. 11 factorial is 39,916,800 over 0 factorial is 1, and 11 minus 0 is still 11. So we have still 39,916,800. Now we have 3,628,000. So we have 3,628,800 divided by 14,400, and 39,916,800 divided by itself is just 1. Multiply it to 1. Now 3,628,800 divided by 14,400 is equal to 252. This means that out of 10 students, therefore, if our committee will be comprised of all boys, there will be 252 possible committees. Our third condition is at least 4 are girls. With this, we can have 2 possible cases. First, our committee can have 4 girls with 1 boy, since 5 students will, since we will be having just 5 students in our committee. And the second case can be all are girls, or we have 5 girls and no boy. Or we can just say that we have 5 girls and no boy at all. And now we combination of 11 taken 4, since out of the 11 girls, only 4 will be chosen, times the combination of 10 boys taken 1, since out of the 10 boys, only 1 will be chosen. This is 11 factorial over 4 factorial times 11 minus 4 factorial. Times, we have 10 factorial over 1 factorial times 10 minus 1 factorial. 5 girls. Now we get 11 factorial is 39,916,800 over 24 times 7 factorial, which is 5,040, times 10 factorial is 3,628,800 over 1 factorial or 1 times 9 factorial or 362,880. We have 39,916,800 divided by 24 times 5,040 is 330 times 3,628,800 divided by 362,880 is 10. Multiplying this, we have 3,300. Meaning, or this tells us that we can have 3,300 combinations of forming a committee with 4 girls and 1 boy. For the second case, we have 5 girls. This gives us then the combination of 11 taken 5 times the combination of 10 taken 0. 11, since we have 11 girls, and we will be choosing 5 out of the 11. Now here we have, out of the 10 students, 10 boys, no student will be chosen. We get 11 factorial over 5 factorial times 11 minus 5 factorial times 10 factorial over 0 factorial times 10 minus 0 factorial. This is now 39,916,800 over 120 times, so we have 120 times 6 times 720 times, this is 0 factorial, so now 10 factorial divided by 10 factorial is just 1. Now, 39,916,800 divided by 120 times 720, we have 462. Meaning, we can have 462 different combinations when forming a committee of 5 girls, or all girls with no boys. Now that we have 2 cases involved in this, or under this condition, we are not yet done. We have to add the combinations for these cases. Then, continuation, we have 3,300 combinations of forming 4 girls and 1 boy, plus 462 combinations of forming 5 girls. This is equal to 3,762. Tell least 4 girls. This involves having a committee with 4 girls and 1 boy, or a committee with all girls. We will now proceed to our next and last example. For letter D, or the last condition that we have, there are 2 boys and 2 girls. With this, we have a combination of 10 taken, meaning out of the 10 boys, only 2 will be chosen, times the combination of 11 taken 3, meaning out of the 11 girls, only 3 will be chosen. We get 10 factorial over 2 factorial times 10 minus 2 factorial times 11 factorial over 3 factorial times 11 minus 3 factorial. Now we have 10 factorial is 3,628,800. Check. Okay, now your 2 factorial is 2 times 10 minus 2 factorial, or times 8 factorial. We have 80,640 times 11 factorial is 39,916,800 over 3 factorial, that is 6, times 11 minus 3 is just 8. So 8 factorial is 40,320 for 8 factorial. But multiply it to 6, our answer will change, giving us 241,920. Then 3,628,800 divided by 80,640, we have 45 times 39,916,800 divided by 241,920, we have 165. The product of 45 and 165 is 7,425. These 10,000s of that are 7,425 possible combinations of forming a family with 2 boys and 3 girls. For our last example under combinations, we have, from a standard deck of 52 playing cards, how many different ways can 7 cards be chosen if? Letter A, there are no restrictions. Letter B, all cards are black cards. And letter C, 3 cards are diamonds and 4 are spades. A deck of playing cards consists of 4 different suits. You have heart, we have clubs, we have with spades, and lastly we have diamonds. Now, diamonds and hearts are considered red cards, while clubs and spades are considered black cards. Each suit has 13 different cards, 9 of which are numbered 2 to 10. For spades, we have 2, 3, you have 4, 5, 6, 7, 8, 9, and 10. Meaning, each suit has 9 numbered cards, and we also have 1 ace, and the 3 remaining cards are face cards. The jack, queen, and we have king. There. The same labels are, the other 3 suits, the remaining suits have the same labels with their corresponding suit. This time, let us solve the following problems. For the first condition, there are no restrictions. With this, 52 factorial over 7 factorial times 52 minus 7 factorial. We have 52 factorial, that's 7 factorial times 45. We have 7 factorial times 45 factorial. We have 52 factorial over 7 factorial times 45 factorial. Then this gives us 52 factorial is already a very large number, so we will simplify this right away. 52 factorial, you can use your calculator for this. 52 factorial divided by 7 factorial times, we have 7 factorial times 45 factorial. That is equal to 133,784,560, which tells us that there are 133,784,560 ways of choosing 7 cards from the 52 playing cards. So let's check. We have, okay, our answer is correct. Now next, we have all cards are black cards. Remember from what I told you earlier, our black cards are the club cards and spade cards. Where we have 13 spade cards and 13 club cards, giving us a total of 26 black cards. So our N is 26, and we are to take or choose 7 cards out of the 26 cards, giving us 26 factorial over 7 factorial times 26 minus 7 factorial. We have 26 factorial over 7 factorial times 19 factorial. This will already be a very large number. So we will be computing it right away using your calculators. That's 26 factorial divided by 7 factorial times 19 factorial. 19 factorial. Leaving us with 657,800, which means that we can have 657,800 ways of choosing 7 cards if all these cards will be black cards. Okay? Next, for item letter C, we have 3 cards are diamonds and 4 are spades. We have the combination of 13 taken 3. Our N here is 13 because again, we have 13 diamonds, and choosing 3 cards out of the 13 diamonds will give us this notation, 13C3 times 13C4. Because again, we have 13 spade cards and we have to choose only 4 spade cards out of the 13. This then will be 13 factorial over 3 factorial times 13 minus 3 factorial times, again, 13 factorial over 4 factorial times 13 minus 4 factorial. Now, our 13 factorial is 6,227,020,800 divided by 3 factorial multiplied to 10 factorial is 21,772,800. Times again factorial. Oops. You have 4 factorial times 9 factorial, giving us 8,709,120. Simplifying this, we have 286 times 715, leaving us with 286 times 715. The product is 204,490, which means that there are 204,490 ways of choosing 7 cards out of the in choosing 3 cards and that are diamonds and 4 cards that are spades in a deck of 52 playing cards. For letter D, we have all cards are face cards. Take note that for each suit we have 3 face cards and we have for suits diamonds, hearts, clubs, and spades. For our face cards we have Jack, King, and Queen. So these 3 face cards times the 4 suits, we have 12 face cards. A total of 12 face cards. Meaning our N is 12. So we have the combination of 12 taken 7. Since we are only to choose 7 cards or 7 face cards out of the 12 face cards. We have 12 factorial over 7 factorial times 12 minus 7 factorial. And that's 12 factorial over 7 factorial times 5 factorial. We do not have to enclose it with parentheses anymore quantities. We have 7 factorial times 5 factorial. And 12 factorial is 479,001,600 over 7 factorial times 5 factorial is 604,800. 479,001,600 divided by 604,800 is 792. So let's check. Okay, we have 792 ways of choosing 7 cards from a deck of 52 playing cards, such that all these 7 cards are face cards. This is our answer. That's 790. Last example and condition, we have 2 cards are red and 5 are black. We have 26 red cards. We also have 26 black cards because in a 52 in a deck of 52 playing cards, the card can either be just red or black. Either way. Now, we'll have the combination of 26 taken 2, since out of the 26 red cards, only 2 will be chosen, times the combination of 26 taken 5, because out of the 26 black cards, only 5 will be chosen. That would be 26 factorial over 2 factorial times 26 minus 2 factorial times, we have 26 factorial over 5 factorial times 26 minus 5 factorial. This is then 26 factorial over 2 factorial times 24 factorial. Times, you have 26 factorial over 5 factorial times 21 factorial. We will no longer expand 26 factorial, 24 factorial, and even this 21 factorial because these are very large numbers in scientific notation. So we will just compute this right away using your calculators. You have 26 factorial divided by 2 factorial times 24 factorial. This gives us 325 times, again, you have 26 factorial divided by 5 factorial times 21 factorial times 65,780. So let's check. Okay, and for this we have, alright. Now, the product of these two factors would be 21. You have 21,378,500. So let's see if our answer is correct. It would always be better to check whether your answer is right. Alright, our answer is 21,378,500, which tells us that there